And that's due courtesy of the encryption that's being done. And the double-edged sword is that if the packets are encrypted, the big IP appliance doesn't have much ability to do application awareness of what's really happening in those packets. And as a full proxy, along with the possibility of using additional modules on the big IP to manipulate and work with that data, that's a problem. So, my friend, here's a solution. When Bob connects to the virtual server IP address, for example, let's say we have a new virtual server at .178, 192.168.1.178. We could actually have the big IP with its own digital certificate terminate the SSL session right there. So we'd have one secure session between the user and the big IP appliance. And then if we wanted to protect this leg of the journey also between the big IP and the backend servers, and if these servers on the backend were also supporting SSL/TLS, we could set up another SSL session between the big IP appliance and those backend servers using once again SSL/TLS. So then we can have the best of both worlds. We have secure traffic here, we have secure traffic here, and we also have the ability to see the naked traffic because we decrypted it at the big IP appliance. We can see that data, see the payloads, and manipulate it as we need to. Now, the other challenge is what if the overhead is simply too much on all these backend servers? One of the options we could do is not use SSL on the backend at all, but simply use SSL between the client and the big IP, and then just use regular unprotected HTTP between the big IP appliance and the backend servers. Did I say unprotected IP? I guess I did. And one of the really cool benefits of having this big IP appliance, this F5 appliance, as the front end for all of the customers' requests that are coming in, whether they're HTTP or HTTPS, is that if there's some issue or problem, for example, with a certain flavor of HTTPS or certain subcomponent, for example, maybe TLS version X has some known issue, what we can do is modify those profiles on the big IP appliance in policy, and all of a sudden we no longer have that risk. We can simply disable that specific flavor or issue that has the problem, and it's covered. Now compare that to just having these servers, for example, behind a firewall. We'd have to go ahead and go to every single one of our servers. And if we have hundreds of servers, it could take days or weeks or months to get to all of them, to individually disable that specific TLS feature that currently has a security vulnerability and we need to disable. What I thought would be really fun for us to demonstrate is let's use our same backend servers, our little teeny Linux implementations. They don't even know how to support HTTPS as a server, or at least not as they're currently configured. But what we can do is we could set up a new virtual server. Let's use .178, 192.168.1.178. And with that virtual server, we could create an SSL profile and apply that SSL profile to the virtual server. And then we can have Bob connecting to that virtual server using HTTPS. And then the big IP appliance can still do its load balancing on the back end to these servers that are just running plain Jane HTTP services. So to pull that off, the big IP appliance is going to need a digital certificate. We could either request and import one from a certificate authority on the internet, or for our lab purposes, we could go ahead and simply create a self-signed certificate for demonstration purposes. We would reference that in our SSL profile and then apply that SSL profile, that client-side SSL profile, to our virtual server. And because we're going to reuse the existing nodes and pool members, we don't need to recreate those pool and pool members. We'll simply reuse those objects with the new virtual server that's going to be supporting the client-side SSL. So the first thing I think we had to do is let's just verify our basics are in place. Let's go to local traffic and go to nodes. And I have red that's currently disabled. We did that in the previous nugget. I'm going to go ahead and select him, and let's bring him back online by clicking Enable. The reason the status is currently showing the blue square is because I don't have a node level monitor doing a health check on those devices. However, at the pool level, if we go up to the pools, the pool is showing green, and that's because we have the HTTP monitor at the pool level regarding each of those pool members. And if we go over here under local traffic to network map, it's showing us that we have one virtual server, we have one pool, and we have 3 nodes that are currently in that pool, and those nodes are all listening on port 80. So let's close the local traffic section, and to create or to request a certificate, which we'll need as part of the SSL, we're going to go to the bottom here on the left and click on System. And from System here in the drop-down list, we're going to click on File Management. And then from the sub-drop-down, we're going to select the SSL certificate list. And here we have an option to import, or we can click the plus symbol to go ahead and create a new certificate. Or we can click on the SSL certificate list. So what I'd like to do is let's create a new one. We'll click on the Create button over here on the top right. Next to it is the Import button if we were to go ahead and import one from a certificate authority. So we'll click on Create, and let's name this our-self-sign-cert, and the issuer is going to be ourselves. And only the items here that are highlighted are the absolute requirements, and let's call it www.acme.com. I'm going to leave all the other items at their default, and click on Finished down here on the bottom. So now we have a self-signed certificate that we can use as part of our SSL. And again, in a production environment, we want to get a CA signed certificate instead of a self-signed certificate. Why? Because if we had a certificate from an internet-based certificate authority that was participating as part of something called the public key infrastructure, our clients would already have been pre-trained to trust the certificates issued by the CA, and they wouldn't get the error warning about, hey, this certificate can't be validated. And to create an SSL profile, under the local traffic, we'd go down to Profiles. From the sub drop down, we'd go to SSL, and then we have options for client and server right here. Because in our demonstration, we're going to set up client-side SSL, we'll simply go to Client, and we'll simply click on this plus symbol to create a new client-side SSL profile. We'll give it a name. Let's call it Our Client SSL Profile. It's also asking us for our parent profile. By default, it's using the default client SSL profile that came with the F5 appliance. So we'll accept that. And then if we wanted to change any of these attributes and we didn't want to inherit those exact attributes from the parent, we could go ahead and click the checkboxes on the right-hand side to change those specific attributes of this SSL profile. It is using our self-signed certificate, that's the one we just created, and really that's all we needed for this demonstration. So we can scroll all the way to the bottom, click on Finished, accepting all the other inheritance for all the other items. So we've done 2 things so far. We've created a self-signed certificate. Secondly, we've created a client-side SSL profile. Our third step is to create a virtual server that is going to use that client-side SSL profile. To create a new virtual server, under local traffic, we're going to go to Virtual Servers. And from the drop down here, we could click on the plus, or we could click on the Create over on the top right while it's displaying the virtual server list to create a new virtual server. And let's name this SSL-virtual-server, and let's specify a destination address for the virtual server is going to be 192.168.1.178. That's where it's reachable at. The port is going to be 443, but we can just use the drop down, select HTTPS, and it'll automatically populate 443 for us. So the layer 4 transport protocol that we're using with HTTPS is TCP. We can specify a specific client side or server side or both profile. So if we wanted to create custom profiles and apply them here, we could. And even though this is HTTPS that we're going to be using on port 443, we can still use a lot of the attributes from an HTTP profile by specifying it right here. So if we had other specific attributes general to HTTP that we still wanted to use, we could use the default profile, which is what we're doing here for HTTP, or we could create a custom profile and then select it from the drop-down list here. And if we scroll down just a little bit further, our intention is just to use SSL between Bob the user and the Big IP appliance. However, if we had backend servers that were also using SSL, we could create an SSL profile for the client side, which we did, and an SSL profile for the server side, and use both of them in combination with this virtual server. So in our case, here's the Our Client SSL profile that we created. We'll highlight it, and then we'll click on the arrows to move it over to the selected column on the left. Still under the configuration section, near the bottom, we have the source address translation. Let's go ahead and use the auto map again. And that way, incoming requests from a specific source address will be translated. The source address will be translated as that request is fed into our servers. And then as we scroll further down to the bottom, we have the default pool here. And what I'd like to do for our demonstration is use our existing HTTP pool. Now, I know it's called our HTTP pool, and that's because the servers, the members, the red, the green, the blue, all they're doing is supporting HTTP, not HTTPS. And the cool thing is they will never know, because the Big IP will serve up the request via HTTP between itself and those backend servers. So we'll have HTTPS support and security on the client side, and then we'll have naked HTTP on the server side. So there's our SSL virtual server. It's currently showing us up if we click on our network map. And here we have our new SSL virtual server. It's using the pool called Our HTTP pool, which has an HTTP monitor associated with it, and it's checking on the health of these three servers. So our virtual server should be good to go. And that virtual server is at the IP address of 192.168.1.178. And we would want to connect to it using HTTPS, because that's what the Big IP appliance is expecting to receive on that virtual server. So now from a browser, if we connect to https://192.168.1.178, my browser has an issue with that website because it can't verify the certificate that that website is using. In our lab environment, it's the Big IP appliance with the virtual server that's using the digital certificate. So if we click on the little lock symbol with the X on it, it tells us here that the certificate does not match the URL because 192.168.1.178 isn't in the certificate. That's because the common name we used was www.acme.com. It says the certificate is not trusted because it's not signed by a CA that this browser trusts. And that's the bad news. On the good news, it says we are using TLS, Transport Layer Security, version 1.2. So if I just use the F5 key and we lay into this over and over again, because we brought the red device back online, it's now doing load balancing between red, green, and blue, server 1, 2, and 3. And on the front end, we're using client-side SSL, and on the back end, we're using naked HTTP. And in general, when people say, oh, we're using SSL, behind the scenes, it actually could be some flavor of SSL or some flavor of TLS. So saying we're using SSL doesn't always mean we're literally using SSL, as in our case, we literally are using TLS version 1.2. In this nugget, we've demonstrated how we can use SSL on the Big IP appliance with either client-side or server-side or both profiles that are associated with a virtual server. I am glad you joined me for this nugget. I hope this has been informative for you, and I'd like to thank you for viewing. Wouldn't it be great if you and I could have a collection of settings that are like quote unquote perfect that we could apply to a virtual server over and over again for each new virtual server we created? Well, the answer is we can. It's a really cool feature called a profile. Let's begin. One of the earliest lessons I had in working with networking about 3 decades ago was to do group management. For example, if I have 15 users and they all need the same kind of stuff, make a group and put those users in that group. And that's because it's so much easier to work with groups of things, such as users, instead of individual user accounts and customizing every single one step by step. And in that same line of thinking, on an F5 appliance, we can also use something called a profile. Now, a profile is a collection of settings. For example, if we always wanted our traffic at layer 4, which is the transport layer, and that's where we have things like TCP, we could create a profile and apply that profile, that collection of settings, to our virtual server. And the cool thing is, we could use it over and over and over again. So if we have 15 virtual servers, they all need similar settings, we can simply apply the same TCP profile, in this example, to each of those virtual servers. And at the application layer, we have tons and tons of services, including the very common HTTP and HTTPS and DNS, and lots of other services. And what we could also do is we could create custom profiles for each of those types of applications. And then once again, if we need to apply that profile, we simply apply that profile, for example, for HTTP to our virtual server, and poof, that collection of settings for HTTP is now applied to that virtual server. And one of the things that will be prevented from being able to do is have incompatible profiles. For example, let's say that we had a UDP-based profile applied to a virtual server. So at layer 4, it's a UDP-based profile, and then we want to go ahead and apply an HTTP application layer profile. And because HTTP is relying on these services of TCP, these would be considered incompatible, and the system would not allow us to apply both of those profiles to a single virtual server. There are many different types of profiles. We have a services category, a persistence category, and the list goes on. And for each of those types, there is what's known as a default set of profiles. For example, we could take the TCP default profile and use it in combination with a virtual server. And so whatever the collection of settings are in the default TCP profile, those are going to be applied for the TCP traffic that is associated with that virtual server. And in our case, because we have a virtual server that's supporting HTTP, which is TCP port 80, we could also apply the default HTTP profile as a services profile. You can think of it as an application layer profile that controls a group of settings or a collection of settings regarding the application HTTP. Now, one of the challenges that might come up is, what if we don't want to use all of the default settings in these default profiles? We can simply allow the child to inherit all those settings and then simply click a checkbox and change the 5% of the settings that we do not want the custom profile to inherit from its parent. And here's a word of caution. If we do want, for example, the 95% of the settings in the parent to be inherited, be aware that that link of those inherited settings is continuous. So that means that next week, if we go in and we modify the default TCP profile, and we change a few settings from that 95% that the child, the custom profile, is inheriting, those changes will also be inherited on the child, on this custom profile. So as a general rule, we do not want to modify or manipulate the default profiles. And you'll recall I said there's two primary options if we didn't want to use all the default settings. And the second option, which is not recommended, is to modify the default profile itself. But be aware that any child profiles, any custom profiles that are linking to that parent profile, they will also get any new changes that are made to that parent profile. So what I thought would be fun as a demonstration is this. Let's create a custom TCP profile and let's call it TCP priority. And as a parent, we'll refer back to the parent TCP default profile. Now, one of the options, and there's many inside of the TCP profiles, is the ability to modify the IP header DSCP bits, which is the Differentiated Services Code Point, also often referred to as TOS for type of service. And the reason I think it'd be fun for you and I to create this customized TCP priority profile is that we can do a before and after shot with a packet capture, and we can verify in measurable terms whether or not it's making a difference. I also understand that many of you, like me, want to actually prove out packets and so forth by doing protocol analysis as part of your lab environment. So I did some research and I saw a lot of really creative ways of collecting the packet capture information for analysis with Wireshark. And then I thought to myself, is there yet an easier way? And the answer is, I think there is. And here it is. If we use GNS3, and what I'm about to show you does not require any iOS licenses or anything. It just requires you to install GNS3 version 1.x. And here's what we can do. We'll go ahead and bring out two clouds, Cloud 1, and we'll bring out Cloud 2. We'll bring out two hubs, and a hub repeats all the bits it receives on any port on all the other ports. And then let's configure Cloud 1 to represent the external network. And we'll configure Cloud 2 to represent our internal network. And because this is all running on the machine that's running VMware Workstation, we can actually collect the data right here in Wireshark leveraging GNS3. So for Cloud 1, we'll right click, go to Configure, select Cloud 1, go to the network interface cards and say that's going to be the external bridge network, VMnet 0. We'll click on Add, and then we'll click on OK. Next, we'll go to Cloud 2. We'll right click on Cloud 2, go to Configure, and then click on Cloud 2 yet again,